Yeah, having known about the kinetic theory of gas, now we see proceed with gas laws. Gas laws was put in place by several scientists. We have the one of Robert Boyce, we have the one of Jacques Charles, we have the one of Amido Avogadros, we have the one of Gay-Lussac, we have the one of John Dalton, that is Dalton law of partial pressure. We have the one of Graham's law. You understand? Now today we'll be looking at the case of Boyce and probably Charles. But as you subscribe, like and share this video, you'll be getting more of the new videos as we discuss all of other gas laws. Now starting with Robert Boyce law. Starting with Boyce law. Boyce law was stated by a scientist called Robert Boyle. Robert Boyle. Robert Boyle was able to tell us that what, despite the fact that what, that pressure and volume are in relationship, when temperature is said to be constant, the volume of a given mass of a gas, the volume of a given mass of a gas is inverse proportional to the pressure of that gas. What is it trying to say? That is, when the volume of a given mass of gas increases, the pressure will decrease. When the pressure of a given mass of gas increases, the volume will what? Will decrease. That is what Robert Boyce is trying to make us understand. At this point, temperature is said to be constant, and we can describe that to be known as isothermal condition. Isothermal condition, that is a condition to which it happens to be that what, temperature is said to be constant. Now from this relationship between volume and pressure, we have this V inverse proportional to what? P. It simply means that my V is equal to K over what? P. Now what does that mean? My K is equals to what? Vp. Now going by the expression here, we'll be having, since my K equals to Vp, which is the relationship between volume and pressure, here my V1 P1 is equal to V2 P2. That is what it means in this case. Now my V1 simply means initial. Now since this is the expression that connects volume and pressure, my V1 here means the initial volume of the gas, while my P1 here means the initial pressure of the gas. My V2 here means the final volume of the gas, while my P2 here means the final pressure of the gas. Now first, let me throw a little light about volume, temperature and pressure, which are the major parameters, including number of mole, which are the major parameters that are used to depict or to describe the behavior of gas or to undergo some kind of calculations in gas. Now first, volume is expressed in what? In centimeter cube or expressed in decimeter cube. That is to say that what? 1 dm cube is equals to 1000 cm cube. That is standard unit for volume. Now for pressure, for temperature I mean, temperature here is expressed in degrees. Yeah, having known as temperature is expressed in degrees Celsius, we also have it degrees Celsius. Now the standard value or standard form of temperature that is at STP is known as what? Kelvin. That is 0 degrees Celsius plus 273 will give rise to what? T equals to 273 Kelvin. You understand? That is, temperature must always be expressed in standard units, which is what? Which is Kelvin. Then we have the case of pressure. Pressure is expressed in atm, that is atmosphere. Pressure is also expressed in millimeter mercury. Millimeter mercury, that is commonly used. Pressure is expressed in Pascal, that's par. Pressure is expressed in bar, that's barometer, based on its measurements, based on its measuring instruments. Pressure is also expressed in torrent. Torrent as short, tall. You understand? And it's also expressed in Newton per meter square, based on its formula, which is what? Force over meter over area. That is, in this case now, these are the standard units that what? That describe temperature, pressure and what? And volume. Then N, which is number of mole, is expressed in what? In mole. That is, the standard unit of mole is known as what? MOL. That's for what? For mole. These are common parameters that are used to describe or to explain the behavior or gas laws. Now, having known as this to be the Boyle's law, then going by graphical representation of Boyle's law. Graphical representation of Boyle's law is given as this. If it crosses through the origin, it means volume inverse of pressure. If it happens to be that what? It flows through in this manner, it can be expressed in this manner too, from the origin, that is inverse of pressure to volume. It can also be expressed in this form. It can be expressed in this form, having it in a slopy form like this. That is volume over what? Pressure, or volume against pressure. And it can also be in interchange form, that is pressure against volume. It can also be expressed in this form, volume pressure against pressure, or volume pressure against volume, where T is constant, where T is what? Is constant. Where T is constant, where T is what? Is constant. Where T is constant, here also, where what? Where T is equals to what? Constant. This describes what we call Boyle's law. Boyle's law can also be known as Mariott's law. Mariott's law. There's a scientist called Mariotte who also described the way or the behavior of gas, just as the case of what? Boyle's. It can also be described as Mariott's law. Now, for instance, we have to exhibit also. Okay, in order to use this question to buttress more about what we have said so far in Boyle's law, from the illustration I gave so far about Boyle's, I said that Boyle's is having a relationship between volume and pressure, that is V1, P1, then V2, then P2. Now, from the question, we have it to be that 375 cm cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750. Now, it simply means that what? The first volume, V1, is given as what? 375 centimeter cube. Then, my V2 is what? Unknown. Then, my P1 is given as what? 770 millimeter mercury. Then my P2 is given as what? Is given as 750 millimeter mercury. Now from the expression here, we have its V1, but my V1 is 375 times my P1 being what? 770. Then equals to my V2, which is unknown. Then my P2 is expressed as what? As 750. Now divide both sides by 750. Then you have it to be that my V2 is equals to what? 375 times 770 all over 750. Then when you punch it to calculator, my V2 is equals to what? 385 centimeter cube. Now that's the value of the V2, 385 centimeter cube. Now having it like this now, that means I have determined my what? My V2 expressed as this. Now trying to reflect back to what we have said about Robert Boyce, he said that when the volume of given mass of gas increases, the pressure will decrease. Vice versa, that is when the pressure also increases, the volume what will decrease. Now going by that here, now we have it to be that was my V1 here is 375, then the P1 is 770. That is pressure here is 770, volume here is 375. Now when the pressure increased to 385, what happened to what? To the air. So when the volume increased to 385, the pressure now decreased to 750. That simply means that what? That increase in volume bring about decrease in what? In pressure. Thank you. Don't forget to like, don't forget to subscribe, share, so as to get more of our new videos.